Alright, hi everyone. So today we're going to go over long division and one reason why we have long division. So let's go through something that we did before again. Let's do x plus 3 times x minus 2, and we'll throw in another one, x plus 1. Okay, so we're making this a little bit more difficult, and today we're going to do long division. Okay, long division. But to get there, let's go ahead and build up an equation that we can take apart. So I'm going to multiply these together. Let's multiply these two together. X squared plus x minus 6. We just did that just a moment ago. And then we're going to multiply x plus 1. This is going to be fairly easy. We're going to multiply everyone by x cubed plus x squared minus 6x. Then we're going to multiply everyone by 1. That'll be x squared plus x minus 6. I write them in two tiers so I can combine like terms. X cubed plus 2x squared. Negative 6 plus 1 is negative 5x minus 6. Now, here's our starting point. If I start off with x cubed plus 2x squared plus 5x minus 6, and I ask you to factor this, it turns out it's not easy to do. And in Algebra 2, you did learn some methods, and today we're going to review that method. One of the methods, we had a couple. We had long division and synthetic division. So we're going to work on long division today. Now, let's go back and talk about what was long division with regular numbers. Okay, let's talk about what was long division with regular numbers. So if I give you the number 3, so divide 3 by 1, let's use 4 and 3 and 2. Let's use long division to divide this number. 1,432. Just an extra hint on top. Can I divide it by 3? If you add up, the trick for dividing by 3s is if I add up 1 plus 4 plus 3 plus 2, that adds up to 10. Oops, this is not divisible by 3. So I'm going to add an extra number at the end to make this divisible by 3. I'm going to add an extra 2 there. Oops. If I add an extra 2, we are now at 12. And now 12 is divisible by 3. We can divide this new number by 3. Okay. So we're going to take this number and we're going to do some long division to it. All right, first step. Can we match 3 to 1? Nope. So we go, can I match 3 to 14? Yes. The closest thing we can get is 4. So we match, we multiply downward to get a 12, and then we subtract. These are our 3 steps. We match, we multiply, and then we subtract. So these are the 3 steps to long division. And no matter how you learn long division, you're always going to follow these 3 steps. You want to try and match the number first, if possible, as close as possible. Then you subtract, and then multiply, and then we subtract. Here we go. Bring down the 3. Let's do this again. We match first. The way I get from 3 to 23 is 7. That's 21. So we multiply down, and then we subtract. We match. We said 7 again. We multiply, 21, and then we subtract. We match. We need a 4. We multiply, and then we subtract. So these are the steps to long division. Hopefully, you haven't done it in a while probably. You haven't done long division probably in a couple of months. But hopefully this kind of reminds you about what we did. Again, 3 steps. Now, when it comes to polynomial long division, we are going to actually do the exact same 3 steps. The exact same moves that we just did in long division are the exact same moves we're going to do here in long division with a polynomial. So that's what we're going to do. I'm going to ask you guys to do this problem. Here's my example now. I'm going to say x cubed plus 2x squared minus 5x minus 6. And we are going to divide this by, I'm going to pick one of our factors, either x plus 1, x minus 2, or x plus 1. Let's choose x plus 3. Okay, that's one of my factors, yep. So we're going to divide x plus 3 into x cubed plus 2x squared minus 5x minus 6. Now, does it look like it would work? No, not really. It's not obvious. So that's set up anyways. So here we go. We write x plus 3 on the outside. And we write x cubed plus 2x squared minus 5x minus 6. And we are going to do the 3 steps we just mentioned before. We're going to match, we're going to multiply, and then we're going to subtract. 3 steps like we did before. So our first step is to match. Now, what you're matching is not the first 2 terms. We're just going to match the front term. So if we look at that front term here, it is just an x. So what could I multiply x by to get x cubed? I need x squared. Okay, we're going to try to match it. So the way I match from x to become x cubed, I need 2 more x's, x squared. So the first step is to match. Second step was we multiply down, right? To get to that next level, we multiply down. So let's multiply down. X squared times x becomes x cubed. Yes, we matched it. But it's not just x. There's a 3 there, so we have to distribute. So x squared times x and x squared times 3. So plus 3x squared. So take a look here. We match, multiply, and subtract. So if there was a number like 31 up here, wouldn't you multiply 4 by 30 and by 1? By 31? You wouldn't just multiply by the 3, would you? And that's kind of a similar concept here. If x was 10, this would have been like 13. And you would multiply not only the 10, but the 3 also. All right, we matched. Right, that was our matching. We multiply. And then we are now going to subtract. Now please follow this next step. You must do this. If not, you will make a mistake and you'll be in IXL hell for forever. We write a parentheses and we write a negative in the front. Make sure you draw the parentheses because people forget when in times of extreme stress to distribute that negative sign. Now here's the next move I like to do, and hopefully you guys will do it with me. You'll write a negative sign on top. A negative and a positive become a negative. A negative and a positive become a negative. So I am distributing the negative without having to rewrite everything. So this here is really a negative x cubed and a negative 3x squared because our last step is again to subtract, and we're going to subtract downward. Now because we match correctly, doesn't x cubed and negative x cubed cancel out? Hopefully you realize that. Just like what we do back here, when we simplify, we lose a value. We lose that tenths position, or that's the goal, right? So this becomes negative x squared. Combine these two, 2x squared minus 3x, because it's a minus sign, right? Because we distribute that negative sign, because we subtracted, that's a negative x squared. And we're going to be, that's it. That's our first step. We have a couple more terms to go, so we're going to repeat this all the way till we're done. So minus 5x. And now we rinse and repeat. Let's start off over on the top. What do I do to match? Okay, I'll use different colors now. Match. So what am I multiplying to match? I need to match. What could I multiply x by here? What can I multiply x by to get negative x squared? I would have to multiply by a negative x. Would you agree negative x times x is negative x squared? Yeah. So let's go ahead and do that. Negative x squared. And now we have to multiply not only the x, but also the 3, because there's 2 terms there. So that's going to be negative 3x. Okay, so we multiplied. That was our step of multiplying. And then we are going to now subtract. That's the last one in red here. So we'll do negative in the front. Now, be aware, I wrote a parentheses to remind myself to multiply both those negative x squared and negative 3x to make them positive, right? So we're going to change it so this becomes a positive and a positive. So if you notice, I write my signs on top. I do that very specifically so I don't forget them. And it's obvious to me when I'm double checking my work in case I did make a mistake. Right, here we go. We end up with the x squared and the x squared cancel out because they're positive or negative. And negative 5 and a positive 3, that's a positive now, is a negative 2x. And we're going to bring down the 6. Bring down the 6. Okay, once we're ready for our next level, we're not done yet. We have to repeat the cycle once again. And the cycle is going to say let's do this in blue. Oh, let's do this in red. Let's match. First step is to match. How can I make x look like negative 2x? Well, I need a negative 2 then. We match. We multiply downward, right? We multiply to the front. We end up with negative 2x, exactly what I was hoping for. And negative 2 times 3 is going to be a negative 6. And then we subtract plus plus. Please look at this. 2x and negative 2x cancel out. And 6 and negative 6 cancel out. We're left with a 0 remainder. So the answer that we're going to write here, this is equal to x squared minus x minus 2. Now you have to be very careful because depending on what problem you're solving for, they might ask you different questions. So let me go ahead and show you the differences in the two. If I ask you x cubed, what's the problem? X cubed plus 2x squared minus 5x minus 6 divided by x plus 3. So this is straight division. The answer is left over x squared minus x minus 2. And that's what we solved for. We said, hey, if I divide x cubed by x, we end up with x squared. X cubed by x, we end up with x squared. But let me answer a different question. What if I asked you to factor? If we factored it, we would actually have to write both terms out again. Okay? So one question will be divide. If we divide, this is what's left over. Here's a simple example. If I ask you what's 10 divided by 5, the answer is 2. You would agree? 10 divided by 5 is 2. I asked you to just divide, not overthinking. But if I ask you to use a different word and I say factor, what's the factors of 10? Aren't the factors of 10 10 times 5? And this is a simple mistake kids will make. When I ask you to divide, just divide. But if I ask you to factor, I need you to come back and write down all the terms that you use to get the original value. And in this case, the factors of 10 are 2 times 5. Or x squared times x. Now here's the next cool part. If I ask you to continue factoring, well, we could factor x squared here. We can factor x squared pretty easily. And that's something that we worked on in Algebra 1 and Algebra 2, factoring x squared. We use our tool of long division to factor out from x cubed, but once we're x squared, we can do it by hand. What two numbers multiply to become 2? That's 1 and 2. Does 1 and 2 subtract out to become 1? They do. Who has to win? Negative. So I'm thinking this is going to be negative 2 and a positive 1. X, 1, and 2. We need negatives to win, so that's why I'm giving the 2 the negative sign, a positive. Double check, is a positive 1 times a negative 2 a negative 2? It is. So we got the signs correct. And you can see here that these are our original terms. Now, what if I decided to divide out by a different value? What if I chose a different factor to divide out? Let's try this now. X cubed plus 2x squared minus 5x minus 6. And we're going to divide this by x minus 2. Okay, we're going to do x minus 2 and see, do we end up with the same results in the end? So let's go set it up. Long division, x minus 2 in the front, x cubed plus 2x squared minus 5x minus 6. So we have our 3 rules. We're going to 1, match. We're going to 2, multiply. And 3, subtract. Okay, 3 rules. So let's first match. What could I use to match x and x cubed? We're going to match x squared. Okay, step 2. We're going to multiply. We multiply x squared times x and 2. We end up with our line x cubed minus 2x squared. Now you might be thinking right now, look, x cubed and, oh look, doesn't plus and minus cancel out? Oh, you got to be careful. Got to be careful here. My last step here is to subtract. I'm going to throw my little negative sign here, and I'm going to subtract it, and we end up with, careful, this is a negative and a positive, isn't it? So be careful. Please write these little symbols on top. Please write these symbols on top. I've been doing this for what, 30 years now? No, not 30 years. 25 years now. And I still write these symbols on the top. You're a new generation, but you probably make the same mistakes as me. So we end up with having 4x squared here minus 5x. The x cubed cancel out, but the x squareds do not cancel out. We actually end up with 4 of them. So please be careful there. All right, we're going to go ahead and do all the steps again. We're going to match. How can I match x and 4x squared? Well, you need a 4, thank you, a positive 4, as well as an x to make x squared. We matched. Then we multiply downward. Here we go, multiply, multiply. 4 times x. No, 4x times x is 4x squared. And 4 times 2 is 8. That's going to be negative 8. And our third step is to then draw my parentheses and subtract this from our previous step. Negative and positive, we end up with a 3x minus 6. Okay, let's do it again. Match. How can I get x to become 3x? All I need this time is a positive 3. Plus 3. We multiply downward. 3 times what we're dividing by is 3x minus 6. We subtract, and we end up with 0. No remainder. So the answer to this problem is x squared plus 4x plus 3. If I ask you to straight divide, I just want what's left over. If I ask you to factor, though, let's change the wording, okay? Let's change the wording. If I wrote factor x cubed plus 2x squared minus 5x minus 6, the factors are x squared plus 4x plus 3, as well as x minus 2. Those are the factors. Those are the two things that multiply to become x cubed, x and x squared. Well, can I factor this again? What two numbers multiply to become 3? 1 and 3. Does 1 and 3 add up to become 4? How do I know it's added? Because I see a plus sign there. So yes, it does. So we have x, 1 and 3. Plus plus means it's a plus plus. See, it's plus plus. That means that we have plus plus in our factors. And x minus 2. So this is our factored form. And if you take a look, this is what we had originally in our problem when we started. Okay, so we're going to come back to this factored idea a little bit later, but right now I'm just going to go through different examples again of using long division for problems that might not necessarily be easy to look at. And what if we're missing values? So just like in long division, regular long division with numbers, if we're missing a value, we do put a 0. We do have to put a space there. So here we go. Let's look at this problem. 8x squared minus 40a. And then we're going to, 40x, x. And we're going to divide this by x minus 5. Now, I mean, we could just do long division, so let's just do it. And then I'll actually show you some cool things that some of you guys might notice. Let's go ahead and just write it. X minus 5. We're going to divide it out. So divide it out with 8x squared minus 40x. Again, working with long division. Long division is a great way to just start someplace. It's not the most creative way, but it is. It's a method that works. So okay, first step is to match, right? So let's match. What times x gives me 8x squared? So I need an 8x. We're going to multiply. So we multiply 8x by the front and the back, both terms. And we end up with 8x squared minus 40x. Minus 40x. Our last step is to subtract. Flip the sign, that's a negative and a positive. 8 minus 8 is going to cancel out to 0. And negative 40 plus 40 actually cancel out. So we actually have 0 remainder. So the answer here is just 8x. It's that simple, really? Well, if you want, you can double check. 8x times x minus 5, that gives me 8x squared minus 40x. And that's what our original problem is. Now, could you have done this with factoring? Yes, you could have. If I wrote this problem a little differently, 8x squared minus 40x divided by x minus 5. Okay, I want you guys to visually see this. This is kind of cool. What numbers does the front term and the back term have in common? They both have the front has 8. Is there an 8 in the back for 40? Yeah, there is an 8. So if I take it out, we have 1x, let's rewrite this. We have x squared minus 5x. But looking here, don't they both have x's? We could factor that out also. Man, I should have done these both at the same time. So please take a look here. I was able to factor out what's in common. They both have an 8x in the front and back term, first and second term. And now hopefully you can see this, is that they both have a x minus 5 that they can divide out. And we're left with a nice 8x. Just like what we had originally said with long division. Factoring is a lot less time, but is not always obvious. Okay. So I would say in these problems, if you notice that you could factor it out, great, do it. You could save yourself some time. The goal in math is, in the end, getting the right answer. Sure, that's super important, but also have a method that you believe is the fastest method. Which method would you apply? It's like tools. You can use a lot of tools to do the same job. Some are prettier, some will make a big mess. But do you have enough experience to pick the right tool? Okay. So let's go ahead and do one large problem here. This is going to be a large one. And this might have a remainder fraction. So let's go ahead and talk about what the remainder fraction is. So it's going to say x minus 6. I'll set it up. And we're going to divide this by 4x to the 5th minus 29x to the 4th plus 43 x cubed plus 68x squared minus 59x minus 6. Super long problem, right? Seeming like it's really hard. But really it's just 3 more steps than what we were working previously with. It's just 3 more steps. 3 more steps than what we previously were working with. None of the steps are actually any more difficult. It's just more steps to take. What's the difference between a 3-step staircase and a 5-step staircase? 2 steps. Not any harder. So here we go. First rule, we'll go ahead and use colors. 1 is to match. 2 is to multiply. And 3 is to subtract. Okay. Here we go. That's match first. What can I multiply x by to become 4x to the 5th? I need a 4 and I need 4 more x's. That's it. That's setting it up. We multiply down. So we should end up with multiplying 4x to the front and to the back. Remember, you're multiplying everything to the front and back. So we end up with 4x to the 5th, like we said we would. And then we're going to get negative 24x to the 4th. Next step, we subtract. Now, again, remember, write the signs on top. That's a negative and a positive. I can't stress how important this is. Yeah, Mr. Shaw, I'm never going to forget. That, don't do it. You're going to forget. Trust me. And then we should end up with the 4's cancel out. And negative 29 and positive 24. Negative 29 positive 24 give me negative 5x to the fourth. Bring down the next term. And we go again. How can I make x become negative 5x to the fourth? That's a negative 5 cubed. We match, now we multiply down. That's negative 5x to the fourth plus 30. 5 times 6 is 30. Negative is a positive. X cubed. And then we subtract. Make sure you flip the signs. Make sure you flip the signs so you can see it. Because that's a 43 minus 30, which leaves me 13. Okay, bring down the 68 now. We're almost done. 3 more steps and we're done. So we're going to match. How can I match x with x cubed? 13x cubed. We need 2 more. So a positive 13x squared. We multiply that down with 13x. Whoops, wrong color. We're going to multiply 13 by x minus 6. That's 13x cubed. It's always going to be the exact same value beginning when we start because you pick the number to match. Minus, okay, 6 times 13 is 60 plus 18 is 68. Is that right? No. I messed up. 78. 78 x squared. Now, it looks like it's going to be a little messy. Here's our negative. That's a negative and a positive. Let me double check that. 13 times 6 is 60, 78. That's right, negative 78. That becomes a positive. That's going to be a huge number now. I'm getting scared. Let's see. Okay, let's see. Did I make a mistake anywhere? I feel like I... Negative. Oh, did I copy this problem wrong? Oh, okay. We're good. We'll just keep going, okay? There's going to be a huge number at the end. Okay. We're going to end up with a 146x squared. Okay, 146x squared. (146x squared). Bring down the next term. Okay, same thing. We're going to match multiply. How can I get 1 and 146? That's going to be a positive 146x because we need x squared. So x times x is x squared. Go ahead and multiply together. 146x squared minus, I'm going to need a calculator for this. This is kind of going wild. And that's okay. For this problem, it's okay because I wanted a remainder. So 146 times 6 is 876x. Okay, we only have one more step after this, okay? So hang in there. I'm going to subtract. That's a negative and a positive, right? We're going to flip those signs. Now we're going to add 876. We're going to minus 59. We end up with 817. Almost there, almost there. Hang in there. 817x minus 6. This is our last step. To match, we need 817, so that's a regular 817. So plus 817. When I multiply it down, it's going to be 817x minus, I'm going to multiply that by 6, 4,902. And your sign, negative and positive. We're going to minus this by 6. And we end up with 4896. Now, how do you write remainders? This is the last part. How do we write remainders? Well, you write the remainder very simply by writing it plus 4896 9 6, and we tried dividing it by x minus 6. And that's how you write this final remainder. If there is a remainder, you write whatever your remainder is divided by the original value we were dividing. And is that a new concept? It is not a new concept. If I ask you what's 10 divided by 3, we say, well, 10 goes into 3 times, remainder 1 out of 3. We copy what we're dividing by as our final fraction. What is 7 divided by 2? That is 3 remainder 1 over 2. So we've been doing this skill ever since we started. And that's what we're doing now. Okay. So if you do have a remainder, you write the final remainder divided by our original divisor. Okay. And that's it. I'm going to do one more division, and this is an identity. If I write x plus, let me think, how should I write this? X cubed minus 27 divided by x minus 3. Okay, this is a difference of two cubes rule. If anyone remembers the rule, this would become x squared plus 3x plus 9. That's what this rule would lead us to. And I'm not sure if you guys remember this, but it's a cubed minus b cubed is equal to a minus b, a squared plus ab plus b squared. That was the rule that you learned in Algebra 2. You might have forgot it, but I'm going to show you right now. We can do this with long division. And there's something about this because I'm missing my x squared and my x's. So how do we fill in the blank? So here we go. What we do is write a long division, and instead of writing just x cubed minus 27, we're going to add a bunch of zeros to it. We're going to put a 0 where there was supposed to be x squared. We'll put a 0 where there's supposed to be x. You don't need to put a 0, but it's helpful visually to see, hey, there's a space holder there. It's helpful visually to see that there's a space holder there. But if you want, you can just remember there's a 0 and just copy it as you see it. Now we're going to do our same steps. We're going to match. X to become x cubed is x squared. We multiply both terms. That's x cubed minus 3x. And then we subtract. And the big deal is you need to make sure you remember to subtract because that becomes a positive x. Now we don't have a value to bring down. If only you can bring down the 27, it really doesn't matter. Even if you bring down the 27, it's not going to, sorry, that's a squared. It's not going to be able to combine it with anything. So let's bring it down. It's not really going to matter. If you can bring it to 0 also. Both these are just matter of preference. Now we match. I need a plus 3x. Multiply becomes 3x squared minus 9x. And then we subtract. Negative positive. That's a positive 9x minus 27. Last step is bring down the 9. 9 times x is 9x. And we have 9x minus 27. 0. 0 remainder. So as I mentioned before, this rule here can be found out through long division or synthetic division, whichever one you prefer. But if you ever forget this rule on the SAT, you can always come up with it. Okay. And if we have missing spaces between, let's say, x cubed, or if we're missing x squared or x, you can just put a 0 there as a space holder. Okay.